you about IoT Enabling Technologies. So basically, as the name suggests, IoT Enabling Technologies are the technologies that make IoT devices possible. So basically, these five technologies can be considered as the IoT Enabling Technologies. Firstly, we'll see what is a wireless sensor network. So as the name suggests, wireless sensor network is a group of devices that consist a sensor network. So these are the devices that can sense a change in the environment and can report it to the user. The wireless sensor network includes end nodes, routers, and coordinators. End nodes are the devices that does the sensing. So these devices sense any change in the environment and convert the change into an electrical signal. Routers are the devices that are used to route the data from the end nodes to the user's device, like the smartphone. A coordinator is a device that is used to establish the wireless sensor network. So a coordinator uh, sets up the network by establishing routes between the end nodes and the routers and and from the router to the internet. So a Zigbee network can be considered as a best example for wireless sensor network. Zigbee follows IEEE 802.15.4 standard and operates in the 2.4 GHz band, and it offers a data rate of up to 250 kilobytes per second and operates up to a range of 100 meters. So these are the different Zigbee topologies that can be followed. In the first, it is a star topology, which means that a single Zigbee coordinator that also acts as a Zigbee router is used, and all the end devices are connected to the central coordinator. And the second is the mesh. So, as I said earlier, there is a single Zigbee coordinator across any topologies. So, the coordinator is connected to different routers, and the routers enable the routing of data between the end devices. And lastly, the cluster tree. So here, as it can be said, the as can be it can be seen, the Zigbee coordinator acts as the root of the network, and routers act as a subtree. And next, coming to cloud computing. So cloud computing refers to the processing of data at a remote location by a server or a powerful device. So the data collected by end devices which are not powerful enough to process the data can be sent to these remote devices for processing. Cloud computing can be broadly classified into these three classes: infrastructure as a service, platform as a service, and software as a service. In infrastructure as a service, the service provider provides the user with all the required resources, storage, and the software required to deploy the network. The best example for infrastructure as a service is AWS or Google Colab, where the user is provided with all the resources like virtual machine to run the code and the storage to temporarily store the data and the code for deploying the network. And coming to platform as a service, Arduino IDE can be considered as the best example for this type of cloud computing, as it provides the development tools required and the software libraries required to deploy the network. For example, if we have to program a node MCU using Arduino IDE, we can simply do that by downloading the required library for ESP8266 and program the node MCU. Software as a service, MQTT brokers like Mosquito or HiveMQ can be considered as an example for software as a service. In this case, the service provider just provides the software applications, and it is up to the user to deploy the application and the network. Big data analytics. So big data is a broad term, and it can be commonly defined as the collection of data that is too large to be processed at the end devices. So big data can be categorized by the volume, velocity, and variety. Volume is the amount of data that is incoming from the end devices. Velocity refers to the rate at which the data is incoming. Variety refers to the difference in the data being collected. Like a sensor can send images or text data or even audio. Communication protocols. So these are the software part that makes the transfer of data from one device to another possible. So a communication device requires a communication protocol to operate properly. The communication protocol does these three functions basically. The first is sequence control. As said, the sensor data that is collected has to be sent in a sequence, and has to be ordered correctly so that any packet loss can be identified. Flow control, if there is any congestion in the network through which the data is being sent, the data flow but must be reduced, and if there is no congestion and the network is free, the data flow rate can be increased to improve throughput. Retransmission, as the name suggests, the packets lost must be retransmitted so that the network is stable. And coming to the last one, embedded systems, as many discussed many times, embedded systems are specific hardware designed to run specific software for to perform a specific task. Embedded system basically consists of four main components, that is processor, memory, networking, and input of IO devices. Processors, so embedded systems mainly run on microcontrollers and sometimes on microprocessor based on the applications. And DSPs can be also used in terms of if the audio has to be processed is audio or video signals. Memory, so basically the memory in an embedded system can be broadly classified into two: data memory and code memory. And for data memory, it refers to the memory that is used to temporarily store the data that is collected from the environment using the sensors. RAM is an example of data memory, and for storage, program memory or code memory, we can use either flash memory or ROM. In today's world, like the devices like ESP32 and ESP86 commonly use flash memory. Networking, as said earlier, IoT devices has to connect to the internet to be called as IoT. So there has to be some type of connectivity, either wired or wireless. Ethernet can be classified as a protocol that can be used for wired connectivity, and Wi-Fi for wireless connectivity. IoT devices, embedded systems used for IoT need not have these IO protocols like displays and keyboards. So basically, they can be programmed using CLI or command line interface.